Hello everyone, this is Revant Reddy Koda and my teammate Mohammad Ashfaqur Rahman, and our topic is about fake news detection and hate speech detection. In today's world where digital information is more accessible than ever, we are facing a big challenge with rise of fake news and hate speech. These issues threaten the quality of public discussions and impact the well-being of individuals and communities. In this presentation, I'll dive into these critical issues and explore how natural language processing can be used to help detect and reduce misinformation and toxicity across different online platforms. What is fake news and hate speech? Fake news refers to information that's either fabricated or intentionally misleading, often shared as if it's actual news to deceive readers. The goal might be political, financial, or ideological gain. And about hate speech. Hate speech, on the other hand, includes abusive or derogatory language targeting people or groups based on characteristics like race, religion, ethnicity, sexual orientation, gender, or disability. And these both have the shared characteristics. Both fake news and hate speech can have serious negative effects like weakening social bonds, inciting violence, and threatening the well-being of vulnerable communities. The importance of detecting fake news and hate speech are informed decision making. So, accurately detecting fake news helps people make informed decisions and maintain trust in reliable information sources. And protective vulnerable groups. Effective hate speech detection can protect marginalized communities from targeted harassment and discrimination. And by promoting social harmony, like combating the spread of misinformation and toxic content, we can create a more inclusive, respectful, and collaborative online environment. Challenges in fake news and hate speech detection. Evolving tactics. The techniques used by people spreading fake news and hate speech are constantly evolving, which creates a big challenge for detection systems. These individuals use sophisticated methods to get around detection algorithms, making it hard to spot their harmful content. For example, some use natural language processing techniques to craft more convincing fake news, or they use code switching to avoid detection. Context sensitivity. One of the biggest challenges in detecting fake news and hate speech is understanding the context in which it's shared. This means taking into account like cultural, linguistic, and social nuances in online communication. A comment that, for example, a comment that might be offensive in one setting could be harmless in another. And data scarcity. Another major obstacle is the lack of reliable, labeled datasets for training detection models. These datasets needs to be extensive and cover the different forms of fake news and hate speech across various platforms and languages. Collecting and labeling this kind of data takes a lot of time and resources, especially for emerging languages and platforms. And ethical consideration. Balancing the need for content moderation with protecting free speech and privacy creates a complex ethical dilemma. When developing and deploying detection systems, it's important to carefully consider these principles to make sure they're implemented fairly and transparently.
Hello, this is Ashwakur Rahman. I'm here to talk about the NLP techniques for the detection. Here we have four techniques such as lexical analysis, semantic analysis, text classification, and entity extraction. And coming to the lexical analysis, in NLP, lexical analysis involves breakdown text into smaller meaningful units called tokens like words, phrases, and punctuations. This is a key step in detection tasks such as semantic analysis, where we identify the emotional tone of the text or named entity recognition, which helps out specific information like names and location. By tokenizing and normalizing the text, converting words to their base forms, and identifying parts of speech, lexical analysis helps us understand the language structure better, which improves the accuracy of models used in spam detection and also topic modeling and many more. It also allows us to detect the emotionally charged words like fake or radical that might flag fake news or the hate speech. For example, a fake news article claiming that a political was caught in a scandal might use intense language to create a false narrative. So, and we can talk about the next. And coming to the next technique, which is semantic analysis. In NLP, it goes deeper and also focusing on understanding the meaning and context of words and sentences beyond just the literal interpretation. Techniques like word embeddings represent words in continuous vector spaces to capture semantic relationships. Semantic role labeling identifies the roles that words play in a sentence, while sentiment analysis assesses underlying emotions. These techniques are essential for tasks like intent detection understanding user for the user queries more accurately and information retrieval, where we can match the documents more effectively based on meaning. By applying the semantic analysis, NLP systems get more accurate context-aware understanding of text. This especially uses for distinguishing between the legitimate criticism and hate speech, like when the comment criticizes like a politician policies versus when it targets their race or religion. Coming to the third technique, which is used in NLP for detection, is a text classification. In NLP, it involves sorting text into predefined categories based on its content, which is vital for many detection tasks. This usually involves machine learning algorithms such as support vector machines, logic regression, or deep learning models like convolution neural networks or recurrent neural networks. Text classification is widely used for the tasks like spam detection, sorting emails into spam or legitimate, and sentiment analysis, where we label text as positive, negative, or neutral. With this feature, technique like TF-IDF or word embeddings model learn patterns with text data, enabling accurate classification. Also, one of the so now the text classification is helping NLP systems handle large amount of text data efficiently and meaningfully. So this is very helpful, and we can use it for different classifications. And coming to the next, entity extraction. It is also one of the important technique in NLP, which is also called in short as NER. It identifies and categorizes the key information from unstructured text into predefined groups like names of people, organization, location, dates, and many more. This is typically done with machine learning algorithms, including methods like conditional random fields and advanced deep learning models such as bidirectional LSTM networks. And these models leverage context to boost accuracy. This is essential. This entity extraction is essential in applications like information retrieval, where it improves search results by finding the relevant entities, and in chatbots, where it helps understand user queries accurately. By effectively extracting entities, NLP systems gain valuable insights from text, making data more organized and user interaction with the context-aware responses. Thank you.
Feature engineering and data preprocessing. It contains three steps: data collection, data cleaning, and feature extraction. I'll explain in detail about it. So, data collection. In the first step, it involves gathering raw text data from various sources such as websites, social media, databases, or user-generated content. So then we compile a diverse and representative dataset that captures the range of language used relevant to analysis. And then we clean the data. Once we get the data that collected, we clean it, remove the noise and irrelevant information. This task includes like removing punctuation, special characters, and stop words. Additionally, this step may involve handling missing values, correcting typos, and standardizing text formats to ensure consistency. Then, feature extraction. After cleaning the data, the next step is to convert the text into numerical representation that machine learning models can process. Techniques such as bag of words, term frequency, inverse document frequency, and word embeddings are commonly used. These methods help capture the semantic meaning of the text and create a structured dataset suitable for model training and analysis. And the conclusion and future directions are continued advancement, further research and development in natural language processing, machine learning, or data science will help create more accurate and advanced systems for detecting fake news and hate speech. With improvements in deep learning architectures like transformers, these models can become better at understanding subtle language patterns. Plus, advancements in data augmentation and techniques will allow for larger, more diverse training datasets so models can handle a wider variety of text formats and styles. Second, collaboration and multidisciplinary approach. To build effective solutions, we need collaboration across field technology experts, policymakers, and social scientists and community stakeholders all have a role to play. Cross-disciplinary research helps us understand the social, cultural, and psychological factors behind the spread of misinformation and hate speech. This collaboration can lead to strategies that address the root cause of these issues. Third, and proactive and holistic strategies. Beyond just detecting misinformation and hate speech, we also need proactive, holistic approaches. Educational programs that teach media literacy skills can also help individuals critically evaluate information and recognize potential biases. Social media campaigns and community engagement initiatives can also promote ethical online behavior, encouraging a more responsible and inclusive digital environment. Thank you all.